Today we're starting lesson 2 on page 81, and you're going to notice a lot of similarities between this lesson and lesson 1. This one is called Explore Division Patterns with Tens, Hundreds, and Thousands. Again, we're going to be working with numbers that are those multiples of 10, and you're going to be able to use what you learned in the multiplication lesson the same way we're going to do in division as well. When we were learning multiplication with it, you learned about using a basic fact and finding the basic fact to multiply by, and then include the zeros at the end. We're going to be doing the same thing, but with division and using some basic division facts to help us solve more complex division problems. So at the top, here's what we're going to be able to do. I can use basic facts, patterns, and place value to divide a multiple of 10, 100, or 1,000 by a one-digit number. To get us started thinking about it, we have a story problem about the Golden Gate Bridge that you see here. It is a famous landmark in California. A toy store has a model on display of the bridge made out of blocks. The model is made using 9,000 blocks. Before it is put together, the blocks are stored in 3 bins. Each bin has the same number of blocks. How many blocks are in each bin? And we're asked to show your thinking. Okay, so sometimes it helps to think through what exactly it is that we're trying to solve and what an equation could be that we would need to set up that we are trying to solve to get the answer. So if we know how many blocks there are in total, which is 9,000, and we know that those 9,000 blocks are divided evenly between 3 bins, that means we're going to take that 9,000 and divide it by 3. Ooh, big equal sign there. And that's going to equal our unknown number n that we're trying to solve of 9,000 divided by 3. Okay, so to help us think about that, if we have 9,000 blocks, we're dividing them into 3 groups. I'm going to make 1, 2, 3 groups. And I'm going to represent the number 1,000, or I have 9,000 here, with a T to show 1,000. So when I think through dividing, if I have 9,000 divided by 3, I'm going to space them out one at a time. 1, 2, 3, 4, 5, 6, 7, 8, 9. I might write down here to help me know that my capital T there equals 1,000, equals 1,000. Okay, so now we have a model that we've made to represent if we had 9,000 divided by 3. If I know that this capital T stands for 1,000, and I can look and see how many of those T's are in each of my 3 groups, that will tell me what 9,000 divided by 3 would be. Well, if this is 1,000, I have 1, 2, 3,000 in each of these 3 groups. So that tells me that my unknown number up there at the top of 9,000 divided by 3, n equals 3,000. Okay, now I want you to look back up at the equation at the top. Do you see a basic fact there? How about 9 divided by 3? 9 divided by 3 is 3. And then let's look at the zeros that we had in our first number in the equation, and it had 3 zeros. Is that the same answer that we came up with from our model?